Today's talk is titled Testing That Your App is Accessible to All. So let's get started. To start, I'd like to say a couple of words about some accessibility misconceptions. I have talked to several developers, and from there and from my experience, teams working on a product quite often face this kind of misconceptions. I don't want to blame developers, designers, or product managers. I don't want to blame anyone for this. We are all people. We all forget things. We all not know how to do things, and so on. But I guess these misconceptions is something important to notice and to think about when building a product. Well, the first one is accessibility is a separate feature that we'll add at some point in the future. Well, I disagree with this one. Accessibility is not really a separate feature. It should be part of most stages of the development process, including planning, designing, implementing, testing, and so on. So quite often, accessibility features are invisible. For instance, like semantic labels are not visible in Figma. Well, nobody puts them there. So they're like not mentioned during planning or design phases. And it's easy to forget about accessibility when you look at some beautifully designed features and focus on those, how they work, how they look from user's perspective. But yeah, you don't remember you forget about accessibility stuff. So accessibility could be like an invisible layer in that sense. So the next one is that only 0.1% of our users will use it. Well, that's just an assumption. According to World Health Organization, there's about 1.3 billion people currently experiencing significant disability. That's about 16% of the world's population. And accessibility is not only about screen readers, how many may think. It's dark themes, font sizes, contrast, understandable icons and illustrations, and much more. So many things that many, if not all of us, could and would benefit from. The next one is accessibility is hard to implement, test, and maintain. We better focus on cool new features. Well, this is often driven by maximizing companies' revenue. And I don't get it, it's understandable because companies are built to make money in the first place. But making app accessible can make your app more usable, can make your users happier, can let broader audiences use your app. It also benefits people and existing users with temporary disabilities, such as someone with lost glasses who might want to use a larger font size or contrasty colors. And the next one is nothing's going to happen if we don't add it. Well, that's not entirely true because there's a new EU Accessibility Act that requires some apps and services to be accessible. For example, e-commerce, banking, e-books, ticket and transport services will have to comply with this act. Penalties and legal consequences are not clear at this point, but it seems that customers will be able to file complaints. So some organizations are exempt from these requirements, but this act still encourages those companies to make their services accessible. So quite often these misconceptions lead to apps being inaccessible. I won't be telling how to make your app accessible today because we are focusing on testing. So let's just imagine that your app is accessible and supporting accessibility is part of your app development process. Then you probably have a question, how do I know that my app is still accessible after all new features that I've recently built? Or rather, how do I test and maintain accessibility on a good level? There are several options. First option is not to test your app accessibility. It's still an option, not the best one, but still an option. But seriously speaking, if your app was once made accessible and then many new features were built, then it's quite possible that the app is not as accessible as it was before. And the next option is manual testing. Manual testing is basically using Android and iOS accessibility options to see how app behaves in different conditions, non-standard font size, small or large, different screen densities, bold text turned on, animations turned off, and so on. So manual testing needs to be done on each or after each development cycle to make sure that the app is still accessible. You might even think of hiring a person to do that if your app is big. However, this might not work for smaller companies or startups. Because of a lot of manual work, accessibility is often forgotten about and abandoned. We're developers, we like computers to do things for us, or at least help us do things. So something that could help testing your app manual is the accessibility tools package that we've been working on. It has a set of toggles that can help you check how your Flutter app behaves when font is huge or tiny, or with bold text setting on, with different text directions, and so on. I personally use font size settings all the time, just to check if my layouts break, in case I forgot to use expandable or expanded or flexible widgets, or if I have a container with a text and the container's height is fixed, or if the text overflows and so on. So that's quite handy when building apps. But it does even more than that. It also helps you find possible accessibility issues when you're developing your app. Some sort of analyzer that highlights widgets without labels and other potential issues in your running Flutter app. This doesn't replace other testing approaches like automated testing, but it definitely helps you finding accessibility issues at the very early stage. It helps building your app with accessibility in mind from day one. And finally, automated testing. Well, Flutter team has built several great guidelines that you can use in your widget tests. Guideline is a checker that ensures that UI widgets are following certain accessibility recommendations. So there are several guidelines available in the Flutter test package. So first one, a guideline to check top target size. There's actually two of them, one for material design, one that follows material design like standards, and one for iOS design handbook. So if your app has a tappable area, or every single app has it, then this guideline will check that this tappable area is big enough. For material design, it's like 48 by 48 pixels, and for iOS, it's 44 by 44. Then there is a guideline to check that all tappable areas have semantic labels. So if you have a widget that user can tap, then it should have a semantic label. And the third one is a guideline to check that all texts have sufficient contrast. So this guideline goes through all nodes of the semantic tree, looking for widgets like text or editable text. It calculates contrast ratio based on light and dark colors and compares that value to the value from some accessibility standard. It's also possible to build your own guideline. I'm going to show that later on. But not everything can be tested with accessibility guidelines and automated tests. But it's a very good start and a very helpful thing to have, especially if you have existing widget tests where you can just add this stuff. Yeah, but sometimes you gotta test things manually. So how do I use these guidelines? Well, you can add them to your existing widget tests. To check if your current UI state meets an accessibility guideline, you need, first of all, enable accessibility in your widget tests by calling widgettester.ensureSemantics. And you should also remember to keep what it returns in order to dispose of it later. Next part can be added somewhere in the body of your test. It should be added to the place where and when you want to check if guideline is met. So, for example, it could be done after pumping a widget, or after going to a different screen, or after like clicking some button, and so on. So whenever you want to check that your rendered widget meets the guideline, use the expect later function to check against the guideline. The check is done by passing an instance of widget tester and a function called meets guideline, which takes a guideline as an argument. So once you're done with your widget test, dispose of the handle that we got at the very first step. Well, that's it. So now we can also create our own guideline. So in this example, let's build a guideline that checks semantic labels length and indicates an error if the label is longer than, let's say, 80 characters. So we can create our own guidelines by extending the accessibility guideline class, and we would then need to override two methods. First is a text description of the guideline we are building, and the second method is the actual logic to check for issues. So here we get widget tester as parameter and need to return an instance of the evaluation class. So evaluation class indicates the result of evaluating a semantic node by accessibility guideline. So it's either fail or pass. And in this function, the second one, we go through all render views that Flutter has and call a function called traverse, which will check the semantics tree for issues. So we'll create a traverse function a bit later. So this traverse function is a recursive function that returns an instance of evaluation class. And each call to this function takes a semantic node and calls the same traverse function for all children of the provided node. So using recursive function ensures that all nodes of the semantic tree are checked. And then for each node, we check if we should ignore it. Node is ignored if it's merged into parent or invisible or hidden. And it's quite important to ignore such nodes because we don't need to check nodes that are not visible to the user or cannot be accessed by the user and so on. And finally, we're ready to check this node's label length. Let's get nodes semantics data first, and then check label's length. And if label is longer than 80 characters, we indicate that label should be shorter by adding evaluation.fail to the result. And the last thing in the traverse function is to return the result that we've been collecting for all nodes. And well, that's it. So now we can use our guideline. It can be used exactly the same as any other guideline. So we need to use the expect later and meet guideline functions and pass an instance of our guideline that we have just created. So Flutter will check the evaluation result when running a widget test and after calling the expect later, and the test will fail if the guideline is not met. And as a side note, it's not only the guidelines that can access the semantic tree in tests. You can access the semantic tree in tests if you need to check something. For example, you can print the entire semantics tree to the logs if you want to see what's there, or you can simulate accessibility traversal and then check the order of the semantic nodes. So this could be useful to ensure that screen readers are focused on the up bar first, or whatever widget you want to be the first one, then on text field, and then some other widget, and so on. So you can also perform actions like scrolling, copying, pasting, moving cursor forward and backwards, and so on. So this could be useful for checking the semantics of a custom widget if you have one. But what if we were able to run existing widget tests by checking how they work with a bigger font size, or with animations disabled, or with bold text setting on? As far as I know, it's not available out of the box, but it's still possible with a bit of extra work. So what I'm trying to do here is to change several flags and run all my existing tests. So the flags I'm interested here, but of course, like this list could be longer. So I want to disable animations. I want to change text scale factor. I want to change bold text flag. I want to change a high contrast flag. So I'm going to use Flutter's Dart-defined command line option to let my tests know that I'm running them in a special mode and all these flags should be changed. So let's call this flag test flavor. So running test is exactly the same as before. We can use the Flutter test command. We can then check this flag inside the test and change certain values accordingly. If you ever use Flutter flavors, then you know what's going on. And then when test flavor is set to accessibility testing or whatever value you choose, we're changing values to values we want to use for testing. So for example, text scale is changed to 3.0. So if flag is not set, then the default values are used. For example, text scale is set to 1.0. We can then wrap our widget into customized media query to emulate a larger font size and some other options turned on. This is like a simplest example, like simplest possible example of how to do that, but I hope you got the idea. It also requires some changes to your tests. However, if you're building page tester classes or app tester classes that help you test all your pages or your app, then it could be easier for you to set up because you probably need to add it to one place or several classes instead of all the tests. So this way, you can run your existing tests in different conditions. Tests may fail simply because layouts overflow or tester can find a widget to tap or to interact with. So my talk is coming to its end, and I'd like to encourage you to check how accessible your app is by checking it manually with a bigger font size, for instance, or like adding accessibility tools packaged to your development workflow, or maybe checking out Flutter accessibility guidelines, trying to add them to your existing test and see what's happening. So yeah, that would be it for today. So I'm sharing these slides and code samples from this talk on my GitHub, so check it out. Yeah, thanks for having me today. If you have any questions, I can try answering them. But if you have any questions later, you can visit our stand and ask them there. Thanks.